Hey guys, it's Chris Field here. Today we're going to talk a bit about 3D printing. So, what is 3D printing? 3D printing is the process of creating a three-dimensional object by building it layer by layer using a 3D printer. This technology allows you to create physical objects from digital designs that's coming from CAD programs using a variety of materials, including plastics, metals, ceramics, and even living cells. We may talk about this a little bit later, but some examples of living cells is we've actually been able to print some crazy things like muscles and even like working lungs and hearts. We haven't yet put these in people, but it is a thing that is being done. The 3D printing process begins with a digital 3D model created using computer aided design, or CAD, as I mentioned in the last slide, software, or obtained from a 3D scanner. So these scanners are pretty neat. You can put something, we'll say a pen in there. It will scan every single dimension of it, and you will literally give you on your computer the exact dimensions of it. The software slices those models into thin layers, which are then sent to the 3D printer. The printer then builds the object layer by layer, following instructions from the computer, of course. So, how are we using this? We've talked a little bit about this. There are many applications of 3D printing, including rapid prototyping, manufacturing, product design, and even just education. This allows designers and engineers to quickly create and test their designs, making the design process faster and more efficient. It's also being used in medical fields to create prosthetic limbs, dental implants, and even organs. Quick note on the dental implants. My father is a denturist, meaning he makes prosthodontics. He actually has himself a 3D printer. He can take digital molds of people's mouths and create the different prosthodontics that these people need, catered exactly to their mouths. It's even more accurate than taking a mold of their mouth and casting that with all sorts of different stones. It's pretty neat. How's Norway using this? Norway specifically is using 3D printing, just like anybody else, really. Printers are found in individual homes, but a unique aspect from Norway is their maritime aspect. Let's check this out. This is a prop cast from metal. I'm sorry, it's not cast. This is a 3D printed prop. This prop was actually printed on a boat as needed. So a boat had destroyed its own prop, running over something, who knows what, and they were able to print this on the spot. So that creates a unique aspect where people can create or carry less spare parts. Instead, they can carry the materials to make spare parts. So whatever they need. Why 3D printing? 3D printing is quick and easy. Materials can be on hand, as I mentioned on that last slide, instead of extraneous spare parts, creating the ability to create new parts at whim or as needed. It also drives innovation, people creating small, unique bits for applications that no one knew they needed. A prime example of that, there are some little tiny curved holes for training plants to grow a specific way. So people are trying to train their plants to, we'll say, an apple tree to grow sideways. They have these little tiny things people made so that they bend the branches and they grow that way. Pretty neat. As far as mass adoption is concerned, it's pretty difficult to predict. Some of the problems that we're having at the moment aren't just the programming or the hurdles of teaching people the programming process, but the creation of items is not meeting the tolerances that we are still getting from cast goods or machine goods, meaning that, such as that prop there, things that need to be made to a precise measurement, we're just not quite there. We're talking down to millimeters or nanometers, even.